solve equations that have rational exponents in them, all we're going to do is we're going to go backwards through that order of operation. So if you take a look at that first problem right there, we have 9 times x to the 3/5 equals 72. So if I treat SADMAP as if it's a checklist of things to take care of, I first have to undo any subtraction or addition that I see in that problem. But when I look at number 1, there's no plus or minus, so I don't have to worry about that. However, when I think about SADMAP, the next 2 letters in that little mnemonic device are D and M. That stands for division and multiplication. Well, at this point in time in problem number 1, I do see some multiplication. Yeah, it's right in there. Do you see it? 9 times x to the 3/5. This means I can get rid of the multiplication by 9 by dividing both sides by 9. So what I have now is x to the 3/5 equals 72 divided by 9, which is 8. Now, I need to remind you about something. There's a way that we can get rid of fractions in math class, and I just kind of wanted to show you a little bit of that. You don't have to write this down, purely for your visual entertainment. Let's say I gave you an equation like 3/4 x equals 6. Can anybody tell me a quick and easy way to get rid of that 3/4? Luke? No. This is multiplication by a factor of 3/4. So there's 2 ways you can think about it, James. Yeah, we multiply by the reciprocal. Is that what you're going to say, Connor? That's with perpendicular lines. Yeah. This is just straight reciprocal, yeah. And here's why that works. So you ready? If what I do to the left side, I'll have to do the right side, of course. So if I multiply the left side by 4/3, I'd have to multiply the right side by 4/3. But let me remind you about why this works. You know when you multiply fractions, you multiply straight across. So 4 times 3 is 12. 3 times 4 is 12. And then 12 over 12, that's just 1. Essentially, it gets the x all by itself. Do you remember that? So if I want to get rid of a fraction, I can actually multiply by that reciprocal, and then what I get is just a quotient that equates to 1. So how can I apply this now to get rid of 3/5? You got an idea there, Peyton? Go ahead. You would, yeah, very good. So do you see how we have 3/5 here? I can actually raise that to the 5/3. And if you think about why that's legit, all I'm doing is raising x now to the 15 over 15 power. 15 over 15 is just 1. And x to the first, well, that's just x. So it's like that 1 doesn't even need to be there. Poof, x is now by itself. You're all familiar with the golden rule of algebra. What you do to one side of an equal sign, you must do to the other. Yes, very good. So if I raise this entire left side to the 5/3, I have to raise the entire right side. So even if there's other stuff over here, I also have to raise that to the 5/3 power. You might remember from our board work earlier in the week, or from that worksheet that you had afterward where we had to simplify rational expression or rational exponents. This is actually the same thing now as the cube root of 8 raised then to the 5th power. The cube root of 8 is 2. 2 to the 5th is 32. So 32 is the number I could plug in for x to make this a true statement. Are there questions about the process before I do another one? All right, let's do it again. So I have x minus 4 raised to the 2/3 power. You again want to treat SADMAP like it's a checklist of things to take care of. So do you see how there's subtraction or addition as the first 2 letters? Be careful because this minus 4 is actually in parentheses. So I can't just go ahead and add 4 to both sides first. I actually need to get rid of the exponent first. So if I want to get rid of 2/3, what would I multiply it by? 3/2, yeah. So I would do 3/2 over here and 3/2 over here. But I have to issue at this point in time a word of caution. You might recall that when I go to think about simplifying this radical, I'm actually now square rooting both sides. And when you square root both sides of an equal sign, you need a plus or minus in your answer. So this is plus or minus the square root of 25. And then you could put the 3 underneath, but most of the time we just tuck that cubed outside the radical. At the end of our exercises today, I want to make this easy for you. The hard part of this lesson is remembering the plus or minus. The skill itself isn't too bad after I do a couple more. So the question I'd like you to keep in the back of your mind is, when do I need to think about putting a plus or minus in my work? Because there's a pattern that comes out for when I need it and when I don't. So here I had to do it because I ended up square rooting both sides of the equal sign when I put this 2 in the bottom of my fraction. So think about that for a second. So now I can just go ahead, now that I have my plus or minus in there. I know what the square root of 25 is. That's 5. And then I have to cube that still. So I get x minus 4 equals plus or minus 125. Remember, this breaks apart into 2 little mini problems. You have x minus 4 equals positive 125, and x minus 4 equals negative 125. If I add 4 to both sides, in the top one, 4 plus 125 is 129. And then if I add 4 to the other side, negative 125 plus 4 is actually negative 121. For your visual entertainment off to the sideboard here, I did number 2 just to kind of show you that you could just jump into these problems, all of them right away with radicals. So that's what I did off to the sideboard here. So if you're a person who's kind of still a little bit shy about using rational exponents and then their reciprocal to kind of undo them, you could automatically, step 1, just turn your equation into a radical equation instead. So I just wanted to let you know that, do you see how I got the same answer here? As I did over here? You could do it either way, you're going to get the same thing. Yeah, Shanice. That's what we're trying to think about today, when I have to square root or 4th root or 6th root. The other ones don't happen very often, the 4th root or 6th root, but if you end up square rooting both sides, yeah, for sure, we think about that plus or minus being in there. And that's the question. After I get through number 4, I'm actually going to throw that question back out to the class and see if we can answer it. It's like our last question of the day. All right. Number 3. Do you know how to get rid of that 1/7? Yeah, multiply both sides by 7 over 1. Good, Shanice. So multiply both sides by 7 over 1. So that goes away. Notice I am just going backwards through the order of operations. This time around I'm peeling off any multiplication or division that I see. I saw multiplication by a factor of 1/7. So I just multiply both sides by the reciprocal of that. I now bring down what I have left over. So I have x plus 9 raised to the 3/2 power equals 49 times 7, which is 343. I now need to get rid of that rational exponent. So if I want to get rid of 3 over 2, I'm trying to teach you today that I could just multiply this by 2 over 3. What I do to one side of an equal sign, I must do to the other. So essentially what I just did on that left side was I raised the quantity of x plus 9 to the 6 over 6 power. 6 over 6 is just 1. So these things just go away. So now I have x plus 9 left over on the left side of the equal sign. Notice I'm going to now raise this side to the 2/3 power. which is like cube rooting 343 squared. Well, if you cube root, do you need a plus or minus? No. Very good. So cube root, you don't have to worry about that. The sign is what it is. So now what I'm going to go ahead and do is take my x plus 9, bring that down. The cube root of 343 is 7, and then I'll square that. So the cube root of 343, if you're wondering where I got the 7 from, that's where that comes from. And then I had to bring down my squared, and then 7 squared is 49. Subtract 9 from both sides, that's 40. And that's the number that would work when you plug it back in. It is, I just need to remind you, important to make sure you're still checking for extraneous solutions. Like I said, these are radical equations in disguise, so we could actually get an answer that doesn't work when you plug it back into the original. But I checked these and they're good. Alrighty. Anybody want to tell me what I would do first on number 4? Go ahead, Tyler. Nice. He is. Oh my goodness. 556 minus 44. What are we, like 512-ish? Yeah. I wouldn't divide yet by 16. No. I need to get rid of that 3/4. So I'm going to go ahead and do what, Tyler? Yeah. Wow, boom. But when I do, that's hilarious. Okay. $16x is on the left side. And then I have 512 now raised to the 4/3 power. If you remember that. Ooh, Darian, go ahead. Yes. So you cube rooted the 512, right? And then you raise that to the 4th power. Keep in mind I cube rooted, so do I need the plus or minus? No, very good. So we got 16x equals the cube root of 512, then raised to the 4th. Darian, what did you get with the cube root of 512? You cubed it. Oh, I see what you did. So you cube root 512 and you got, what was the number you said before? 8. And then you raise that to the 4th power. And that's where you got your 4,096. And then what did you do? Nice. So we get, yeah. There it is. You can plug it back in to check it. It does work. Okay, so now I want to throw you my final question. There's really only one case where I had to think about a plus or minus hanging out in our lesson today. Can anybody establish a general rule for when you have to think about using it? Tyler. Okay. Yes, so that is good. And then Cody? Ah, very good. So honestly, when there's a 2 on the top, that's really going to be the place where you have to think about it. Every once in a while, there'll be like a 4 or a 6 on the top. That's super rare and probably not at all likely on a test. So yeah, we'll stick with when there's a 2 on the top, but keep in mind it's anytime there's an even number in the numerator, you would have to think about that plus or minus. Questions about our lesson today? Okay, I want to give you a hint about your homework before you leave me today. You have 4 book problems for tonight, 4. And it's not like there's a part A and a B, it's just 4 problems. 4 like this. Okay, I have to tell you though that on the first one, there's 1 answer, but on the last 3, there's 2 answers. I didn't check this last row, so I'm going to do that now. So yeah.